So, good afternoon to all of you. As Professor Hussain was saying that it is difficult to preconcentrate or to separate the viruses from the algae, and similarly there are many other methods, that is from the beginning, that we need some preconcentration, or means to increase the concentration of the substances for the analysis. And there are many methods by which we can increase the concentration. You can listen to me. There are many methods by which we can increase the concentration of substances for the analysis. Now, for the analysis of substances, two things are very important. First is we should get the clear, pure substance, that it should be free from the impurities, it should be free from the interferences, means it should be free from the interferences. It should have no interference in the analysis, during the analysis. And second thing is, its concentration should be so much that we can analyze it. We can analyze it means it is within the detection limit of our instrument, that our instrument on which we are working is so much sensitive, so much is so capable of detecting the substance at very low concentration, because you see day by day impurities at very low trace levels are increasing. Many substances are present at very viruses are present, as ma'am was saying, and metal ions are present, and many other pesticides are present, drugs are present. All drugs we don't need for our safety. All drugs we don't need for our safety. So, some drugs they are not required for our body. So, for this the question is, that is from where the sample from where we need to apply the preconcentration, that is from where the samples are coming. And you will find that from the environment, from the wine, from the drugs, from the pesticides, from the food, all these things are contributing for the pollution, or they are going to deteriorate our environment. Like this industrial pollution is very much, and drugs are there, and from the environment and in food. So, that is our sample. It can be in the food, in the cosmetics, in the biological tissues, environmental samples, various like metals, titanium dioxide, silver, iron oxide, silica, gold, and wine, and other foodstuffs. For all these things, the sample preparation is very, very important before the analysis. And analysis, it depends on particle size, distribution, concentration, composition and shape. Now, there are some of the techniques by which we can carry out direct analysis, like ICP-MS. Some of you have heard of ICP-MS. You have heard ICP-MS. Using ICP-MS, like if in your sample cadmium is present, zinc is present, copper is present, then you can directly analyze these samples. Means there is in ICP-MS also there is interference of other substances. Means there is interference, but for most of the metals ICP-MS is suitable for the direct analysis. And phase separation, and then is extraction of nanoparticles, matrix decomposition and preconcentration. So, these steps, these are done for the analysis of the samples, and different techniques like AFM, XRD, DLS, HDC, SEM, TEM, for different materials they can be applied for the analysis. So, I will try to introduce you to the most of the advanced sample preparation techniques for environmental analysis. There are many techniques, and by which you can analyze the samples below the detection limit of your instrument using these techniques like solid phase extraction, solid phase micro extraction, and hollow fiber liquid phase micro extraction, and other is computational methods, functional materials. Functional materials, they have pores of different sizes, and depending on your analyte size, you can preconcentrate these using functional materials. Other is matrix solid phase dispersion, and liquid micro extraction, and there is QUECHRS. We follow some of the parameters for quality assurance analysis, and that is known as QECHRS. So, preconcentration, you can understand. Now, what is preconcentration? You take any method. Preconcentration means increasing the concentration of the analyte in your solution, in your matrix. So, preconcentration means to increase the concentration of the sample prior to analysis close to the detection limit. There are organic samples, like for example, we can do preconcentration for a non-volatile organic sample with evaporation in a solvent, and that is process. What is the preconcentration process? If we define what is a preconcentration process, then we can say that it is the process in which the analytes are transferred from a larger mass to a smaller volume, and the micro components, that is, they are transferred to a smaller organic solvent by extraction. Like you can see that in this is more volume. Now, if you decrease the volume, then this analytes volume is decreased, that is, they are present in a smaller solvent volume. This is known as preconcentration. This is preconcentration, that is, analytes, they are present now in a smaller volume. So, there is a long history of micro solid phase these extraction methods, and how most of the students who are with organic chemistry, they separate their prepared materials, or they purify with the help of column chromatography. And so, the main milestones in the development of solid phase extraction, like in 1950s, in very earlier pipes, they were filled with activated charcoal. Now, if you see what is the best material for your adsorption studies, anyone can tell me? The best material for adsorption studies is activated charcoal. It is the cheapest material. Silica or other modifications are done, these materials came later on, but activated charcoal is the best material for your, because it is carbon, and carbon is non-active, non-reactive, and it is not reacting with other chemicals under the normal room temperature conditions, right. And in the late 1960s, various porous materials were introduced, and in 1970s silica was considered, and in 1980s short pre-column materials were introduced, and in 1989 particle loaded membranes, they were used for the extraction, and in 1992 solid phase micro extraction was invented, and it was brought to the market. And in 1994 molecularly imprinted polymers, they were introduced for the extraction, and in 1990s, like multi-wall plates for high sample processing, they were introduced, and many more techniques they were introduced for the extraction. I will introduce you all of these techniques for the extraction. So, for chemical analysis, what we need? Like if you have vegetables, you have fruit, meat, or you have lemon, that is, and you want to measure contaminants like mercury or lead in food, what you will do? If you have mercury, lead, or other contaminants in your food, then you have to prepare your sample with acid, with the heat, acids, and dilutions. If you are doing metal analysis, I am saying metal analysis, then you can use heat and acid. But if you are using if you are carrying out your analysis for the organic pollutants like pesticides or PCPs or other hydrocarbons, then you cannot use acid and heat. Then you can analyze the metals using your with a suitable technique. So, question is if we do not prepare samples, means if we do not make the sample ready for before analysis, what will happen? Whether you will be happy or not, whether the results will be accurate or not. This is the question. That is, for preparing the samples before injection into the instrument. Injection into the instrument means taking the sample for analysis. You take any technique. For that you have to prepare the sample. That sample should be ready for injection. Means it should be homogeneous, it should not be heterogeneous. If you take heterogeneous sample, concentration will not be concentration will not be uniform. Means if you take heterogeneous sample, mean either it will settle down, or the analytes they will settle down, or they will be non-uniformly distributed. So, it is not nice to inject the sample before the analysis. So, this is the question, that why do we need sample preparation? That is, analytes, they are contained in a complex sample matrix, and we must separate them. And like if we are carrying out MS, or we are carrying out HPLC analysis, like we want to analyze only these only few peaks of the sample, but in our sample we find there are coming so many peaks, and which are unwanted peaks. And there must be many baseline interferences. Now, like this peak is baseline interference, and this peak is many baseline interferences. Now, you add your analyte to it, and they will interfere in your analysis. Means you will not, they will give you higher amounts. So, another thing is that the particulates, they may limit the instrument, and your analysis time will increase. If you are using chromatographic methods, then plugging of the columns may take place, and analytes which are contained in a complex sample matrix, they complicate the analytical results, and the sensitivity of the instrument will not be very high using non-prepared samples. Like if you see this one, you get only a small peak if you do not prepare your sample, and if you pre-concentrate it and using a chromatographic method, then you will get a more detectable peak, and this peak will be, you can analyze it. So, similarly, if you are analyzing like a protein in a complex sample, then there are small peaks, and if you precipitate the sample precipitate the proteins, then about lot of proteins they are lost and analysis is not possible. So, using precipitation, like 80% of the ion suppression takes place, and if you take solid phase extraction, I will come to you what is solid phase extraction. Then you can see that there is about 100 or 200 there is a lot of peak increase, and this shows that pre-concentration step is necessary. Another thing, sample matrix cleanup is taking place, baseline interferences are removed, and if you are using mass spectrometry, it reduces the ion suppression in the MS, and the pre-concentration processing in pre-concentration, the sample processing step makes you for ready for the injection for HPLC, GC, UPLC, GCMS, LCMS, atomic absorption and other methods. There are for pre-concentration methods, like there are 3 types of pre-concentration techniques. That is, first is flow through the equilibrium and pre-equilibrium. Another is batch equilibrium and pre-equilibrium, steady state, exhaustive and non-exhaustive. We can divide it into flow methods into 2 types, exhaustive and non-exhaustive. And exhaustive, these I will explain as you will come. Purge and trap, Jordan trap, solid phase extraction, supercritical fluid extraction, and PFE method. And another non-exhaustive is the in-tube SPME method. Another is batch equilibrium, it is exhaustive and non-exhaustive. Exhaustive methods like liquid extraction, Soxhlet extraction, Jorban's, and microwave assisted extraction may be taking place. And non-exhaustive headspace, liquid micro extraction and solid phase micro extraction. And steady state exhaustive and non-exhaustive extraction method are the membranes. You can prepare different membranes, and using those membranes you can carry out the extraction. And first is that is miniaturized solid phase extraction technique. Miniaturized means that is only on a very small scale. Solid phase extraction methods, that is, this includes SPE, solid phase extraction, SPME, magnetic solid phase extraction technique, stair bar adaptive extraction, and immunoaffinity solid phase extraction, and microwave micro extraction in packed syringes, and dispersive micro solid phase extraction. So, like you have a sample, what is the procedure for the solid phase extraction? That is for calculating the recovery, that is how much of the analyte you can recover. You have a blank sample matrix, you add analyte to it, spike to it, then using that is spike is done, then you carry out the solid phase extraction and analyze the extracted sample, and from the recovery of the extraction, that is 100 into response of the extracted sample and response of the post extracted spiked sample, that is from the comparison of two, we can find the recovery of the substance. And we can also find the enrichment factor, that is concentration of the analyte metal like and concentration of the normalizer, and Cm over Cn, that is the baseline noise, or enrichment factor is final concentration over initial concentration, because enrichment factor is the equilibrium between the substances adsorbed on the column and separation. So, make the sample clean. Analytical scientists mainly they are trying to develop for gas chromatography, for HPLC, various techniques for the enrichment of analytes, and for this there is a signal for, that is for the signal enhancement at the baseline. So, many techniques are used. One of the technique used largely by us also is the solid phase micro extraction technique, and this is a very simple technique. In this the fiber, there is a silica fiber which can be modified by various substances, and there is modified syringe like instrument. Fused silica fiber is at the base and cylindrical geometry. It is connected to a stainless tubing, and the silica fiber is coated with a thin film of several polymeric stationary phases, and the fiber assembly is reusable and replaceable, and small size cylindrical geometry of the fiber. It offers various advantages into the that is, it can be employed either in the sample, or it can also be employed using head space. I will tell you what is head space analysis. Various advantages is that for SPME is that it is organic solvent free. We do not use any organic solvent because it only involves the adsorption. Highly sensitive analytes, they can be it can be applied to the ppm, ppb range, short extraction type, and easy to use, and it do not require any other sample preparation method, and it can be easily automated. So, for the analysis, HPLC is the simplest technique for high pressure liquid chromatography, and in the coming lectures I will also introduce you to the liquid chromatography and the various advantages that simple to operate, fast, highly sensitive, applicable for qualitative, quantitative purposes, small sample size is required, and wide spectrum of application, and it is applicable to polar, labile and non-volatile compounds, and high efficiency, more flexible in operation parameters, and reusable columns, and safe to use. So, I will show you how we can attach HPLC to the, this is the SPME HPLC hyphenation attachment done in our laboratory, and this is the SPME holder, and in this it is the online process, that is during the analysis the sample is desorbed in this desorption chamber. The mobile phase which is coming from the reservoirs desorb the sample, and it is subjected for analysis. So, like it is the desorption, it is the injection valve. We we don't need to need any other we do not need any other solvent for the desorption of the substances, analytes, only the mobile phase which is used for the analysis, and so we can use for the direct analysis using SPME at a very low level, at very, that is at ppb or ppt level, using SPME. And for head space analysis, like you have a vial, and in the vial you just you do not dip the fiber in the sample, you just hold the sample above the liquid surface. If your sample is in the liquid state, or if your sample is in the even in the solid state, then if it is volatile then it is very good. If it is not volatile, then you little heat the substance and it will be adsorbed on the fiber surface, and then you can make its elution in the desorption chamber. So, we have this is the commercial SPME device, and this is the lab made SPME device in which we have taken a silica fiber, and we have done the various polymer coatings on this fiber surface, and it is we have made suitable for the analysis. So, using SPME, that is we can have a monolayer coating, or we can have a bulk coating, or we can have a coating on the capillary, then it is known as polymerized material, that is in tube coating. So, we can directly inject the sample inside this tube, and the sample can be in the first step you do not connect this to the rheodine valve, and after that replace it, and after allow the sample to pass through it, and when the sample is adsorbed on it, then inject a volume of the solvent, or you pass the mobile phase through it, and online desorption will take place. So, I have already told you that is that working with SPME, and in the market different category of fibers like PDMS, divinyl benzene, PA, polyacrylates, and carboxene, carbovax, templated resins, they are available. And like this I told you, that is headspace method and the direct immersion mode. That is, in headspace method you just hold the fiber tip on the surface, and in the direct immersion mode you dip your fiber into the sample, and this is how the inside of the desorption chamber the desorption takes place. So, we have used HPL SPME for the analysis of explosive materials like RDX, HMX, TNT, trinitrotoluene and tetryl, and you can see the nitro explosives and HMX and TNT. You will find that these substances or matrices, they are very difficult to, their samples are very difficult to prepare for the analysis, and so there is metabolites of TNT. You can see we can extract all these metabolites on the fiber. So, we have performed various, we have developed various methods, and one of our this article, and it is almost half of the journal was published with this, means it is 37, that is 39 pages of the article, and it describes all the methods, approaches for the analysis of explosives, because for the extraction of explosive materials, that is RDX, TNT, very few methods are available. So, for selecting the method, like you have to select the suitable wavelength for RDX and HMX, and we can analyze these substances using a suitable wavelength of their maximum absorbance, and we can separate HMX and RDX using HPLC, and we can preconcentrate the materials using SPME. And the best thing was done by us, that we used the surfactant solutions for the removal of pesticide, for the removal of explosive materials from the surface of fiber. That is, these materials were adsorbed on the surface, and then we used the mobile phase, which is containing a little SDS. SDS is sodium dodecyl sulfonate, and it is a surfactant, and it was used for the analysis. And so, that is HMX and RDX, they were well separated, and you can see we can do their analysis in at a very low concentration of 50 ppb, at a very low concentration of ppb. I will tell you one example, that in close to Chandigarh there is a explosive manufacturing unit, and there is lot of RDX, and is manufactured. There is a RDX army unit, and there is a army you can say factory, which is ordnance, which manufacture RDX, and they say that RDX is not present outside their premises, and but we analyze the water which is present outside their factory, and we found that RDX in that is, it was present in sufficient concentrations. So, I will that is different methods, they were developed at very low concentration. You see that is at very low concentration you will see at 20 ppb 20 ppb 20 ppb parts per billion. You can see how much low concentration of explosive materials these were detected, and this work was done by the in the DRDO project, Defense Research and Development Organization. They sanctioned us a DRDO project, and we developed these methods for their analysis. Now I was saying that this interference, that is like this interference is coming, but we cannot remove this peak from the samples at a very low concentration. So they were these RDX and HMX samples, they were analyzed. Like we have all the explosive materials, they were separated and they were analyzed, and that is all the metabolites of TNT and RDX, they were analyzed using suitable concentrations of these. Instead of HPLC, you can use SPME for the gas desorption for gas chromatography also. If you inject your SPME fiber, SPME needle into the gas chamber, gas that is heating unit, then which is above the column, and then it will dissolve the fiber, it will dissolve the explosives from the fiber surface, and then they can be detected by gas chromatography using so many explosive methods were developed for the explosive analysis. And for the extraction of for the reading on the solid phase extraction, there are two books, that is Solid Phase Extraction by E.M. Thurman and Nigel J.K. Simpson. These two books are available. Another is micro extraction by packed sorbents, and you see this is a cylindrical, this is a syringe, and in this is the packing material. This packed material, on this packed material you can modify it. It is a very miniaturized technique, and you can use it directly for HPLC, or you can use it directly for the gas chromatographic analysis. So MAPS, it is called as micro extraction in the packed syringes, and a very low amount of sample can be used, and ejection can be done at very low concentration. So there are many advantages of MAPS, that it reduces the time for analysis, and volume for analysis is used is only 3.6 microliter, and it can be fully automated, and it eliminates all the extra steps which are needed for the sample preparation and injection. So that is we can use MAPS, and it can be modified by different methods, and in the desorption chamber using gas chromatographic conditions, directly MAPS can be used for the MS also. That is we have used for the fragmentation of the nitroaromatics on GCMS, and you can see that all these fragmented products, all these fragmented products which are present in the environment, means like if you take nitriles or terryl or dinitrotoluene, they don't remain in the environment as such, they undergo degradation, and it is necessary to identify the degraded products, and we can identify the degraded products using GCMS, and this can be applied, maps can be applied. So, this is how we have studied various, if you can tell me the time, if 4 o'clock.
5 minutes.
And then you can pH or solvent, or you can select the different conditions for the analysis, like we have analyzed using maps all these tetrahyl 2-amino DNT products, TNB trinitrobenzene, all these means these can be analyzed at a very low concentration.
We have this facility, sir?
Yes,
You have this facility?
we developed this many times.
Okay.
And you can see we have generated this data for the analysis, and about 10 PhD students, they did their maps and SPME technique used, and one of the student, she went to Canada also, did her postdoc, and now she is employed in a institute in Canada as a professor. So you can see that we have that is calculated the limit of detection and the limit of quantifications. They are very low level, and we were trying every time to reach at the lowest possible limit. So I will move to like another technique. We have not used this some like there is Sandeep, he has used this stair bar adsorptive extraction. They have made nanoparticles, and they are stirring it and adsorbing the analytes on the nanoparticles, and so from fruits and using various modifications, these can be stair bar adsorptive, stair bar adsorption can be done, and after that using a solvent, that is you can see that is you have this extraction, we extract it from the water and pre-concentrate it. All the analytes, they are adsorbed on this stirrer, which is made of means adsorbing material, and later on with the desorption we can elute it, and we can use it for the analysis. So another thing that is you can see that SEM and TEM they have been used for the modification of the materials which were adsorbed on the stirrer. So you can see that is how the pre-concentration is that is, this is the baseline, and in the baseline you don't see any analyte, and after the preconcentration, like you can start observing these analytes. Then at different concentrations you can see that is using a very small volume extraction can be done, and analysis can be done. And another is magnetic particles. They are used for the solid phase extraction. In this iron nanoparticles, they are used for the adsorption studies. It is similar to stair bar-job tube extraction. And another method is the immunoaffinity solid phase extraction, that is, in which resin is having affinity for different proteins, and they can be extracted and they can be analyzed. And another is a single drop micro extraction. Single drop micro extraction, in brief, I will tell you, that is, we take in a syringe, gas chromatographic syringe, a drop of the little solvent, non-polar solvent like toluene or hexane or chloroform, depending on the solubility of the analyte, and we heat it, and then we can, after the extraction, inject it upwards and directly inject the sample into the GC gas chromatograph or into the HPLC, and it mixes with the mobile phase and analysis can be done. So, different, like this is the single drop, and you can do it by the head space. Head space means you are using it above the sample, and indirect it is within the sample, because if sample is in water, your organic solvent and this small drop will not fall, means you stir it, adjust the speed of your stirrer, and that is, you can, that direct immersion as single drop micro extraction, and head space you can adjust it, and you can inject into the HPLC or GCMS, like this is the injected in the HPLC syringe, and if you have a GCMS oven, you can inject it. And this is for MS magnetic liquid phase micro extraction for gas chromatographic, that is, nanoparticles, magnetic nanoparticles are used, and after the extraction and desorption can be done, and they can be analyzed. So, another is there are some solvents which change into solids, like we have a this is our analyte, and it is in a solvent. We add some solvent to it, that is dispersive liquid micro extraction, and then we cool it. The this extracting material, this liquid, this dispersive solid which we have added, it will absorb all the analytes, and it will, when we will put it in ice, it will solidify, and just you drain off the upper liquid and you are ready for the analysis, or you melt it and the analysis can be done. And another is direct liquid micro extraction, that is, this is developed in the last decade, and you can see that is after the sonication this sedimentation will take place, and you can inject it, you can take it out and you can inject it. Another thing that is using nanoparticles, as I told you, or these can be modified with various various fullerenes or some other carbon aromatics like magnetic nanoparticles. They are modified with silica dots, and so by this way different approaches they can be developed. So, all liquid micro extraction techniques like single drop micro extraction, dispersive liquid micro extraction, or liquid micro extraction, they can be classified and they can be used. So, and direct liquid micro extraction, what I told you, that is, we insert a small drop of the liquid and then we extract it and separate it. Nowadays another thing is coming it, that we are developing molecularly imprinted polymers, and these are molecularly imprinted polymers are highly specific for a particular analyte, and we create the cavities in the polymer, that we create the cavities in the polymer of the size of analytes, like these cavities, these analytes are removed later on, and these cavities are created, and on these cavities the analytes, the material which can fit into these cavities, they can be analyzed by desorption. This is just like the pant and shirt of a single person who can use it, and no other person can fit into it. So, these molecularly imprinted polymers, that is, they are highly selective and sensitive for the analysis of drugs. I will show you that. Look in this polymer, this small cavity, it is so very good. I was surprised that how these cavities are created in the polymers, and you look here, that this cavity, similarly there are this cavity, that there are cavities in the polymer, and analytes, they can, when we add them to the solution or to the sample, they very specific from the environment, they fit into it and they can be analyzed. So, this is the summary for all the methods for the micro extraction techniques, not in detail, but a brief introduction to the methods, and I will next time we will show you how to use HPLC and gas chromatography is not, but we will have a journey with liquid chromatography, how to use it and how to apply the solid phase extraction for the analysis of analytes. And I will have try to do mass spectrometric calculations to find out the unknown substances. Thank you very much.